So today is September 8th, and you're here for Economics 249. We're going to start Chapter 3 today. What you're looking at on the screen is some information that I sent out with an email about free tutoring. So this free tutoring is available at Queen's College. You can click on the link and they have everything from different econ classes to accounting, and it could be some math courses too. Also, there's free counseling service. So if you need it, please access this important information. Couple of things I want to mention is the chat box. I monitor the chat box. So it's set up in such a way that I can read everything that is communicated to me, to each other in breakout groups or individually. So if you're sending a message to someone else, just one person within the chat box, I can see it. I want to mention the homework. As you may know, the homework due date was extended from this past Sunday to the upcoming Sunday. So your homework is now due September 13th, and I will not change that date. Okay, so what's due on September 13th? You have to finish Chapter 1, Chapter 8, and Chapter 2 homework. And now, since I'm going to begin Chapter 3 this week, you will also need to submit Chapter 3 homework. So it's a lot. Don't wait for the last minute. Make sure you complete it a little at a time. Speaking of the homework, remember I said there are 3 attempts when you're completing the homework. So make sure you use some of the help aids that's available to you if you're really stuck in the middle of a homework. Okay. Yeah. Karina, just hold on a second. I see your message. So if you're stuck when you're doing a problem, make sure you use the help aid. So it says question help, ask my instructor, view an example. You might lose some of the attempts, but it's really helpful because the homework is hard, a little hard for Chapter 2. Some of the questions are a little complicated. So it's fine, okay? Something else, make sure you know how to access all the PowerPoint slides that I post during lecture. So if you do not know how to access the PowerPoint slides, send me an email because it's very important for you to view, review these slides before the next exam. Okay, it's under Course Tools Document Sharing. And the last thing I want to mention before Karina makes a quick announcement is this thing I want to bring to your attention, digital cleanse. So you should start thinking about your future, your career, right? And what your digital presence speaks about you. So I know some of you have a LinkedIn profile. Make sure you have a professional picture or, a decent picture of yourself and all the accomplishments you want to state. But now, if an employer is interested in you, they're not only going to look at your LinkedIn profile, they will also look at your social media accounts. So make sure your social media accounts have pictures of you that are appropriate, something that you would be proud of sharing with everyone. Also, cleanse who you are following in your social media accounts. So even on Twitter or Instagram, make sure you're not portraying some kind of toxic environment. You're not portraying some anti anything. You're not manipulating anyone. And also build your feed so that you surround yourself with a lot of positive things. So for example, I realized, so I did this for my own self a while ago, and I realized that I wasn't really following Black scholars. So I changed my feed and I made sure that I included more Black scholars and more women of color. And this started changing the way I saw stories on my feed. And, I'm presented with different sides of the same coin even. And you need to realize that not every expert is North American. So, open yourself to a different kind of news stories. Okay, so enough of my lecture with digital cleanse. Karina, you can go ahead and mention what it is you wanted to say.
Hi, everyone. So I'm part of a professional business club on campus. And tomorrow we have one of the big five accounting firms coming to have a virtual fireside chat with students to talk about potential employment and internship opportunities. I can send the RSVP link in the chat if you guys want to join our event tomorrow. It's during free hour from 12:15 to 1:30. So if you're interested, please sign up.
Perfect, thanks. And I will also send an email out with the flyer that you sent me. So we're going to start with chapter 3, but before I do that, there is a poll that you should see on your screen, and this is regarding the material we covered in the last chapter from chapter 2. So I'll give you a few minutes to complete this. Okay, so I'm going to end it now. I'm going to stop the poll. And you can see here that most of you chose yes, and that is the correct answer. This is not a trick question. So be careful when you're doing your homework. There are some questions where it asks you to look at the graph and determine whether it's right or wrong. So look at the value it starts with on the vertical axis. Okay, so let's start with chapter 3. So chapter 3 is about displaying and describing quantitative data. So chapter 2 was about organizing and displaying qualitative data. So now we're going to switch to quantitative data. So the first slide says the monthly average stock price for 6 years leading up to a company's financial crisis are shown. So it's AIG, and that's the company, and we're looking at the average stock price for 6 years that led up to the financial crisis, 2008. Okay, so we're looking at a bunch of numbers. These are all numerical values. That's why I'm saying they're quantitative data. So right now it's very hard to tell much from this table of values. You don't know what's the highest, what's the lowest, is it increasing, decreasing, is any particular value occurring a lot? So not much information. So just as with categorical data, we wish to display this quantitative data in a picture to clarify what we see. So with the previous chapter, qualitative variables, we looked at two kinds of pictures, a bar chart and a pie chart. So here, with quantitative data, we display it as a stem and leaf display or a histogram. Okay, so numerical data is also called quantitative data, stem and leaf or histogram. And based on the histogram, you can also display it as a polygon or an ogive. So let's look at a histogram. So now a histogram is a graph, but it's for a quantitative variable. Now what you're looking at is a histogram. So it's basically a bar chart, but the difference here is that there are no gaps, no space between the bars. Because if there's space, then it is not a histogram. This is the histogram for the AIG stock prices that you saw in the first slide. So on the x-axis now, this is monthly average price, stock price. The y-axis is number of months. So immediately I'm getting some shape and meaning to the data. I can see that there are 8 groups, 8 vertical bars that are constructed at the boundaries of each group. So it starts from 45 to 50, 50 to 55, 55 to 60, and so on. Immediately, I can say that the lowest monthly average price was from 45 to 50. I can say that the highest monthly average price was from 75 to 80, and it occurred in the least number of months. So maybe about 2 months, it was between 75 to 80. And the most common monthly average stock price was between 65 and 70. So I can get all this information just by looking at a histogram. So here the y-axis is number of months. And if I switch to percent on the y-axis, it's now called the relative frequency histogram. So slightly different. But we always start at 0 on the vertical axis. So today's class is going to show you how to organize your quantitative data first into a table and then into a histogram. And then I will show you how to create the polygon and the ogive after the histogram. So you will be using Excel, and I will talk about your first Excel assignment that you will do together in a group. So I will split you into groups, and I will assign those groups to you where you have each other's contact information. So that will happen after class today. You will get an email with that contact information. So let's continue with chapter 3. So new example. This is a bunch of numbers, your data. And I'm telling you that the first thing you have to do is organize your data into a table called the frequency distribution table. So let's say I give you this data set, 12, 13, 17, 21, 24, 24, 26, and so on. Step 1, the first thing you need to do to create this frequency distribution table is to make sure you have an ordered array. Now, can anyone tell me what an ordered array is? Do you remember the meaning? Numbers in order. So what would the first number be? If Nayang, you say numbers in order, Diana, you're right, lowest to highest. So the first number is the lowest number, the last number is the highest number. So yes, we start with 12. So looking at this data set, it's actually an ordered array. It has been rearranged in increasing order. So we've done step 1. Step 2 says, now decide on the number of groups or classes that you want. So I'm going to call that G, number of groups. Usually when you're dealing with a data set, we say 5 to 10 groups. It's just a standard that we've picked, so 5 to 10 groups. So I'm going to say, for this data set, I'm going to say, let the number of groups be equal to 5. Why did I pick 5? No particular reason. I just decided I'm going to have 5 groups. Now, what do I mean by groups or classes? It's the number of vertical bars that I'm going to get when I create my histogram. We saw in the previous example that we had, I think, 8 groups, 8 bars. So again, between 5 to 10 is the norm, and I'm picking 5 here. Step 3 is to decide on your interval, your bandwidth. How wide do you want each group? So there is a method to figure that out. We take the highest value in our data set minus the lowest value divided by the number of groups. So what's the highest value here? Okay, 58. Elizabeth, Diana, you say 58 minus the lowest value of 12. And then I have to divide this by 5. So Judah, what you get as an answer? 9.2. Okay, so this is telling me that the interval should be 9.2. So let's say I do 10 to 20. Sorry, let's say I do from 10 to 19. Sorry, let's start again. I'm talking about the interval, right? So according to my calculation, the answer is 9.2. So interval of about 9. That's a bit complicated because I'm saying 0 to 9, and then again another 9, and again another 9. That's a bit complicated. So I'm going to make this approximately 10. Let's say the interval is 10. Now that's a little easier. I can say 0 to 10, 10 to 20. Yes, so Judah, I'm rounding to 10 for simplicity. Although I know that the highest minus the lowest divided by 5 is closer to 9, we're making it an interval of 10. Okay, so now I've done my 3 steps. I'm ready to set up my frequency distribution table. Okay, so the next slide. Okay, it's a bit messed up here, but I think we should be able to see. The first column is class, or I can call it groups. So we decided to have 5 groups. So I have 1, let's see, 2, 3, 4, 5 groups. So I have my 5 groups. Then we decided to have an interval of 10. So here we have 10 to 20, 20 to 30, 30 to 40, and so on. Now, why didn't I start from 0 to 10? Why do you think I did 10 to 20 and then 20 to 30?
Because there's no number under 10.
Exactly. There's no number under 10, right? My first observation is at 12, so it doesn't make sense. Okay. The next column is frequency. Third column is relative frequency, and the last column is percentage. Let's start with frequency. Now, this is telling me it's a class from 10 but under 20. So I'm actually going to count how many observations fall in that category, in that group. So I have the values 12, 13, 17. So those are 3 observations that would fall under 10 to 20. Then I'm going to actually count how many observations are 20 but under 30. So that means I have the values 21, 24, 24, 26, 27, 27, and that's it, under 30. So it's those 6 that fall in the second category. Okay, so just to make sure. And so on. Now, let me see, this is not very clear, but let me try to figure this out. The total for frequency, so I'm just scratching this out, okay? I'm not writing anything here. The total for frequency, when I add everything up, it should give me the value 20. So when I add the column for frequency, I should get 20. That means I have 20 observations in my data set. With relative frequency. Now, I think you remember how to calculate relative frequency. So for 0.15, that would be 3 divided by 20, right? So 3 divided by 20 is 0.15. To get the next value for relative frequency, I would do 6 divided by 20, and so on. Any questions about relative frequency? When I add up the total for relative frequency, I have to get the value 1. So no matter what data set you're working with, when you add up relative frequency, you have to get 1. If you don't get 1, if you get a value that is more than 1, that means you did something wrong, or even less than 1. So you need to go and check to see what it is you did wrong. Percentage is fairly simple, right? With percentage, you just take the value from relative frequency and you times it by 100. Okay, Priscilla, you have a question here. How did you get the first 20 total again? Okay, so when I added up all the values for frequency, it's the total number of observations in my data set. So all this together should be 20. So that's how I got 20 as my total for frequency. Okay. Any other questions before we move on? So basically, this is how you set up your frequency distribution table. It's a summary table constructed in such a way that the data is arranged into several groups or classes. So now taking this information and creating a histogram out of it, if I was using Excel, and I'll show you how to do that, you're going to highlight class and frequency, those two columns, to create your histogram. Okay, so this is your histogram coming up. Okay, so that's your histogram. It's describing the quantitative data that has been grouped into a frequency distribution. The x-axis is all the groups or the classes. The y-axis is frequency. So that's actually cut off. Now, if you look at the number of bars, we have 5 bars because we decided on 5 groups. And you can see that each bar is constructed at the boundary of each class. So that's important information. Okay, so I'm going to say here that each bar, so every point here that I'm kind of trying to circle, is constructed at the boundary of each class. So we have 10 to 20, 20 to 30, 30 to 40, and so on. The values that you're looking at, the 15, 25, 35, those are just the midpoints of each class. Okay, so you can disregard that. All you need to know is when you construct a histogram, you're using the boundaries of each class. Now, it's very important to note that there should not be any space between the bars. There are no gaps between the bars. Okay, so again, it's giving me some shape and meaning to the data. It's telling me what's the highest group, what's the lowest group, meaning what's the most frequent, what's the least frequent. So it's giving me some range, giving me some shape and meaning. If I want to create a polygon, which is based off my histogram, that would be a line graph. So the next slide is showing you, let's see if it changes. Yep, so this is a polygon, a line graph. It's basically the same thing because your x-axis is still classes, your y-axis is frequency, but now instead of using the boundaries of each class, you're going to use the midpoint of each class. So if the boundary is 10 to 20, 20 to 30, 30 to 40, then the midpoint would be 15, 25, this should be 35, 45, and so on. So that's the midpoint. So the midpoint, so if you take 15 midpoint of that class, the corresponding frequency was 3. And the midpoint of 25 was 6, and so on. So a polygon is basically a line graph, and based on your histogram. Any questions? No? Okay, so now you saw how we constructed a frequency distribution table and how we constructed 2 graphs based on that table. The next table that you need to know is this, the cumulative frequency distribution table. So it's a little messed up. I don't know why it comes like that, but it's the cumulative frequency distribution table. So it's based on the previous table, that frequency table. But this table is important because now you can highlight the proportion of observations that lie below each class limit. And that's important. I'll show you when I'm constructing it why that's important. But sometimes we need to know what the total is below each class limit. So I think what I'm going to do is I'm going to create a blank whiteboard space and rewrite this. So again, it's the same data set. Okay, we did step one where we decided to have an ordered array and we rearranged it. We did step two where we decided to have 5 groups. We did step 3 where we have an interval of 10. Okay, so now let me open a blank screen. Okay, can everyone hear me? Okay, good. So we have class, and then we have percentage. Okay, and then cumulative, percentage, frequency. And then we have frequency. And then cumulative frequency. Okay, so you have 5 columns. Okay, and then we said this is going to be 10 to 20, and then let's make it clear. 20 to 30, 30 to 40, 40 to 50, and then you have 50 to 60. Okay, and then percentage and frequency, they're the same values from the frequency distribution table. So that hasn't changed. Okay, so percentage and frequency is the same. So this is 15, then we had 30, then 25, 20, and 10. And frequency is the same as before, so that's 3, 6, 5, 4, 2. So this hasn't changed. Okay, so now what I'm going to do is calculate the values for cumulative percentage frequency and cumulative frequency. Okay. So let's start with cumulative percentage frequency. So the first value stays the same as percentage, which is 15. Okay, that's the same value as percentage. The next value is cumulative, means you keep adding. So we have 30 plus 15 is equal to 45. Okay, so that's from, oh no, I think I erased everything. Oh gosh, sorry. Okay, so let's go back to what I just showed you. There is no undo button. Let me see. There is no undo button here. So bear with me. I'm trying to get back to our slides. Okay. So it should be fine because you got the gist of it. Yeah, and I'm going back to the PowerPoint slides because it's important to get to that. So it's taking a while to load. So we were talking about the cumulative frequency distribution table and the third column, which is cumulative percentage frequency. So the stays the same as percentage. And the second value, you keep adding. Okay, so not sure why it's taking a while to do this. I'm waiting for it to load. Okay, can everyone still hear me? Okay, so can everyone hear me? Good. Okay, so I am back. And I won't be able to write on the whiteboard, but I'm going to share the files that I need to share. Okay, so we were here. Okay, so this is where we are at. And I know this looks messed up, but this is what, let me see here. So we have percentage, and then we also have cumulative percentage frequency. That's your third column. The fourth is frequency, and the last one is cumulative percentage frequency. So percentage and frequency, it's the same values. Cumulative percentage frequency, so the values are 15. Okay, so again, I can do this on this computer because I switched computers. It's, let me write it on the top here. So I'm writing the values for cumulative percentage frequency. The first one is 15. The second one is 15 plus 30. And then you have, so that would be equal to 45. So let me write 45. So then the next value would be 45 plus 25, which is equal to 70, and so on. Does everyone see that? I know it's really complicated, but if you look at the values for percentage, the first one is 15, the next one is 30. So that's why we're doing 15 plus 30, which is 45. The next one is 25. So that 25 is the previous number 45 plus 25, and then 20, and then 10. Okay, so I didn't write the rest. Any questions for me? Okay, so frequency values are the same as before. We have 3, 6, 5, 4, and 2. So that should stay under frequency. Okay. And then the last column, Jonathan, you're asking me, is cumulative frequency under the frequency column. Cumulative. So the last column is cumulative frequency. The second column is cumulative percentage frequency, which is this stuff that I just did here. Okay, so that's an arrow. That's all this stuff. So Jonathan, the cumulative frequency column, yes, exactly. So I think you answered your own question. So cumulative frequency, the values are, the first value stays the same. So that's 3. I guess I circled the wrong one. First value is 3. The second value is 3 plus 6, which is equal to 9. Then the previous value, 9 plus 5, which is equal to 14, and then so on. Okay, so you can fill in the rest. So I know it's super complicated when you look at it, but it's supposed to be really simple. When you open your PowerPoint slides, you should be able to see the accurate values. So this is your cumulative frequency distribution table, which was based off the previous frequency distribution table. I'm going to move on to the next graph that is built off of this, and that graph is called an ogive. So you can see here at the bottom, the x-axis is your class, and your y-axis is now this cumulative percentage frequency. Okay, so let's see what an ogive looks like. So this ogive also has a name called cumulative percentage polygon. So the x-axis is class. So we had values like, let me mark it here, 10, 20, 30, 40, 50, and 60. So those were the boundaries of the class. If we start at 0, this would be, so this is class, and this would be cumulative percentage frequency. Okay. And then we had values starting at 0, and then it was, I believe it was 15. Let me go back and look at those values. 45, 70, 90, 100. Okay, so I'm not going to write it, but you can see the cumulative percentage frequency value of 15, 45, 70, 90, 100. So if I had to draw my ogive, it's basically a line graph. So let me put a few points here. The points at a class of 10 but under 20 was 15, and a class from 40 but under 50 was 90. Okay, so I have my 2 points here. And if I had to draw a line, my line would look something like this. So this is my ogive. Now remember, with the histogram, you built the vertical bars at the boundary of each class. With the polygon, you built it at the midpoints. Now with the ogive, you don't use the midpoint. Dongyan, that's a good statement. It's not the midpoint, but you're using the top of every interval. Okay, so you actually use the top of every interval. So that brings me to the next slide, which actually explains what I just said here. So with the histogram, it's at the class boundaries. With the polygon, it's at the midpoint. And with the ogive, it's at the top of every interval. So it's important to remember that. Any questions for me? No? Okay, so now I'm going to show you the other way of displaying quantitative data, and that's through a stem and leaf display. So a stem and leaf display is very much like a histogram, but they also give the individual values. So we're going back to that AIG stock prices data. The x-axis is monthly average price. The y-axis is number of months. Okay, so this is the same histogram that we saw before. But what's a stem and leaf? Well, the stem and leaf says the stem includes the leading digit. So these are the leading digits, and the leaf includes the trailing digits. So these are all the trailing digits. I'll give you a different example that's easier to understand, and then I'll explain how this is important. So just a quick note, if you turn your head sideways to the right, the shape of the stem and leaf display is very much like the shape of the histogram. So that gives you a clue as to how your histogram is going to look like. And Judah, you say, can you use stem and leaf for 3-digit data? Yes, you can use it for 3-digit data. You would, so let me go to the next slide and kind of show you what, so not this slide because this slide is explaining it. I want to actually do an example with you. So let's look at this data and then I'll show you how the 3-digit example could look like. So this is a new example. This is the data set 21, 22, 24, and so on. First thing you have to do is make sure you have an ordered array. Okay, is your data in increasing order? And in this situation, yes, it is in increasing order. So we don't have to do anything. Okay, so now I'm going to take my first value. Let me write this down here, which is 21. And I'm going to say that's my leading digit. My trailing digit is 1. My second value is 22. So that's 2, comma 2. So 22, then 24, and that's it. The next value is 33. So leading digit, and then we have, so it's 33, 33 again, 36, 38. And my next value is 4, 1. If I had 101, I would do 10 and 1. So that would be my 3-digit data. Okay, so again, it kind of gives me some information about the data set. It tells me what's the lowest value, the highest value, the sample size, how many observations in my data set. It tells me what's the middle value, what's most common, but it doesn't really tell me how the data varies from each other, but at least I get some information. Okay, so now what I'm going to do is I'm going to talk about Excel, because you need to work with your groups to create a frequency distribution table, a histogram, a polygon, a cumulative frequency distribution table, and an ogive. Okay, so the data set you're going to get, it's not the data set that you see, right? Because these are examples. I'm going to tell you to, it's actually the Excel assignment itself is posted on my stat lab. So it tells you to get the data from your textbook. Okay, so there's instructions on how to get that data. Now there's different data sets, and I want all groups to choose different data sets. The data set that you choose is the same set of data you will be using for the rest of the semester. So make sure it's a topic that interests you, because Excel 2 will be about the same data set, Excel 3, and so on. And it's all quantitative data. Okay, so we're dealing with quantitative data. So I'm going to show you now how to use Excel to create these tables and graphs, but using the same example that we did in the previous slides. So this is our data set, right? So once you open Excel and you have your data set, you will have to choose one column from that data set. Okay, so this is the same set of numbers that we saw. And we said step 1, 2, and 3. First, make sure you have an ordered array. We decided on 5 groups. It could be anything from 5 to 10. And this is how we came up with our interval of 10. Okay, so Nicholas, your question is, are we going to report our data to you? Are we going to? Yes, so you will let me know what data set you're planning to use. Okay. So now when you open the data set from the textbook and you put it into Excel, or you download it, it's already in Excel, it might not be an ordered array. Okay, so make sure you rearrange it in increasing order. And this is an easy example because we had 20 observations. In your data set, you might have 100 observations, 200 observations, I'm not sure. So don't do this manually to rearrange the data. Make sure you use Excel. So what you can do is highlight this column A and then click on data, and then it asks you if you want it in increasing order. Okay, so you can do that. And okay, let's move on. So we're good up to here, right? Any questions before I move on? So the next step is to actually create your frequency distribution table. So before I go to the next slide, Karina, to answer your question, you say, when will we get our groups? After class today, you will get an email from me indicating the groups. Okay, so let's look at the top left table. That's your frequency distribution table, right? So you have your 4 columns: class, frequency, relative frequency, and percentage. So class, now you know how to create 10 to 20, 20 to 30, and so on. Frequency, I showed you how to do that. You're actually going to count how many observations in your group and then type it in. Now with relative frequency, again, you're using Excel, so I don't expect you to do it manually. I want you to get Excel to do the work. So the first thing you do is you type in an equal sign. So that means you're telling Excel that you're going to be typing in a formula. Okay, so this equal sign indicates that there's a formula coming up. So you're telling Excel, take whatever is in cell B3 and divide it by 20. Now 20 was the total number of observations in your data set. So that's where that 20 came from. Okay. And then you would copy and drag this relative frequency formula all the way down in column C. Okay, so once you type up this formula and you hit enter, you will automatically get the answer for relative frequency. And then copy and drag the formula all the way down. Okay, any questions about this? Okay, the next thing is percentage. So if we look at the bottom table here on the right,
Professor,
yeah,
can you show the formula again?
so it's on the screen here. The formula is the equal sign,
Mm-hmm.
open parenthesis. So I'll type it up here. So in cell C3, I would do open parenthesis. So equal sign, then type B3, straight right, B3 divided by 20. And that's the formula I would type into that cell. Now, you're not going to have the same set of data, right? You will have different classes, different groups, different number of groups, different total for frequency. So you won't have the value 20. You will have the total number of observations in your data set.
Okay, thank you.
Okay. The next thing is percentage. So if you're looking at the bottom right table, you type in the equal sign and you tell Excel, take whatever is in cell C3 times 100, and that's your percentage. And I don't know if I mentioned this before, but when you add up everything for percent, you should be getting 100. Now again, how do you do adding and stuff in Excel to get the 20 and the 100 and the relative frequency of 1? You can click on this sum button here and highlight the values that you want added and hit enter, and you should be able to get that. Okay, so here is your frequency distribution table. Any questions about that? Okay, so now the next step is to create your histogram. Okay, so remember the histogram is just a bar chart. So let's move on to the next thing. So a lot going on here. Let's take it step at a time. So you created your frequency distribution table. The next thing to do is to highlight class and frequency. So that means highlight this column class and highlight this column frequency. Okay, and then the next step is this. Right click the bars. Oh, sorry, not this. The next step is this. Insert bar chart. Okay, so I'm over here. Insert bar chart. So when you click on insert, you can choose this as your bar chart, and then a simple 2D column is good enough. So if you click on that, you will automatically get this bar chart that you're looking at. Now there's a problem. What's the first problem you need to fix? The gaps. Jeffrey, you're right. So if some of you know a different way of creating a histogram, that's fine. Go ahead and do it. But this is one method of creating a histogram. Okay, so we need to fix the gaps between the bars. So that's where this information comes in. Okay, so right-click the bars, any bar here that you see, right-click it, and then select Format Data Series. When you click on that, choose a gap width of 0. Okay, and that will immediately remove the gaps and your bars will come together and you will have a histogram. Now, if you want to fix this graph with a nice chart title and axis titles, then you would do this. Okay, follow these instructions. So first, click anywhere on the chart and then select chart tools. So chart tools is over here. And then when you click chart tools, add chart element. Okay, so that doesn't show up on the screen, but select add chart element. So that way you can add your X axis title and your Y axis title. And you can also double click this and change the title to histogram. Okay, because you're creating a histogram. Any questions about this? So it's fairly simple, but you're doing it as a group, so make sure you break up the work. Okay, so this is your histogram. The next thing is your polygon. Now remember, the polygon is just a line graph that is actually based on the histogram. So that brings me to the next slide. To create a polygon, so here we are now, we're at the polygon. What you have to do is this. Right-click the bars. So right-click any of these bars that you created for the histogram, and then click change series chart type. It should say change series chart type. And then select line. That would be a line graph. That would be your polygon. And again, in the same way, you can click on chart tools and then change the chart elements and add an axis title and change the chart title and make it polygon. Okay, so you have to play around with Excel to do that. So now I've shown you how to create your frequency distribution table, your histogram, and your polygon. The next step is the next table, which is the cumulative frequency distribution table. Okay, so class is the same, percentage is the same, frequency is the same. What's different is cumulative percentage frequency and cumulative frequency. So for cumulative percentage frequency, the first value is the same as percentage, which is 15. The next value that you will type into Excel is first the equal sign, so that Excel knows you're going to type a formula, and you're telling Excel, take whatever is in cell C2. So cell C2, in our case, cell C2 has the value 15, and add it to whatever is in cell B3, and then hit enter. Okay, so take 15 plus 30, and then copy and drag that all the way down. So there's a reason why I'm telling you to type in the cell numbers, because that way Excel will do the consecutive cell numbers. Okay, and then you can get the same thing with cumulative. Let me change this for this cumulative frequency. So the first value is the same as frequency, which is 3. The next value is open parenthesis, same thing. Tell Excel to take E2 and add it to D3. Okay, so same thing, and then copy and paste it all the way down. Any questions on how to calculate cumulative frequency distribution table? Okay, then to create the ogive, which is basically your line graph, you need to highlight 2 columns. And the 2 columns are class. So you highlight class, entire thing of class. Hold the control button on your keyboard and also highlight cumulative percentage frequency. So since these columns are not next to each other, you need to hold the control button when you're highlighting. Otherwise, it's also going to include percentage column, which you don't need. Okay, so highlight class and cumulative percentage frequency, then insert a 2D line. So you will see on Excel, I think this is insert line, and a simple 2D line is fine. And that's your ogive. Again, you can fix it with the axis titles and all that. So to answer Nicholas's question, we do not need column E for the graph, but you need it for the table when you're setting up your cumulative frequency distribution table. Okay. And I will need each group to print, sorry, not print, but to hand me one Excel, submit one Excel assignment. Okay, so each of you don't submit one, just one per group. Danielle, you say, I don't have 2D line charts in my Excel. If you don't have 2D and you only have 3D, that's fine. I basically need a line graph. And this is due September 17th. Okay, so you have more than a week to communicate, exchange contact information, which you will have, and then submit it. So I haven't decided if you're going to submit via Blackboard or email. I will get back to you on that, and you will get information about your groups after class today. Okay, so I will send all that information out. So I want to go back to the last couple of slides that I want to finish up here for this chapter. So all this time we're talking about a distribution, right? The distribution of your quantitative data. So now when we talk about the distribution, we're saying there's three most important things that we should focus on: the shape, the center, and the spread. Okay, shape, center, and spread. And when we talk about shape, we're focusing on mode, symmetry, and outliers. So these are the three things for shape that's important: mode, symmetry, and outliers. And that's what I will focus on for the rest of the day today. In the next class, we'll talk about center and spread. So starting with shape and mode, does anyone remember the meaning of mode? What does mode mean? Most, okay. Alisa, you say most. Most common. Judah, yeah, let's go with that. So the value that is most common, the number that appears the most. Lewis, you're right. So let's start with mode. If I have a data set, it's the value that occurs the most. Agreed. If I have a distribution, like a histogram like this, now mode is in terms of peaks. So a peak in a histogram is considered a mode. A distribution whose histogram has one main peak is called unimodal. If it has two peaks, like you're looking at here, it's considered bimodal, or sometimes multimodal. Or sometimes, if it's really hard to tell, you're looking at a uniform distribution with no particular mode. All the bars seem to have the same height. Next thing for shape is symmetry. So again, with a distribution, if I draw an imaginary line in the middle and I fold the distribution together, it seems like it's mirroring each other, then the distribution is considered symmetric. But all distributions are not necessarily symmetric. What you're looking at here is right skewed. So this distribution is considered right skewed because it has a long tail to the right. Okay, let's look at this. X-axis is charges in dollars. Y-axis is number of female cardiac patients. Okay, so the number of female cardiac patients is the y-axis. So as the charges increase, as it becomes extremely expensive, then the number of female cardiac patients seems to decrease. So I'll say that again. As the charges increase and as I have very extremely high charges, the number of female cardiac patients seems to decrease. So that means extremely high values pull my distribution to the right, which causes a long right tail, which makes my distribution right skewed. In the same way, this distribution is considered left skewed. So the x-axis is age given in years, and the y-axis is number of female cardiac patients. So if I look at this, now this is telling me that as females, when females are extremely young, so when the age is 20 or less or 30 and less, when females are extremely young, the number of female cardiac patients is very minimal. So these extreme values to the left pull my distribution all the way to the left and create a long tail to the left. So that's why we call this left skew. Any questions? So Nicholas, you're asking me, is this a multimodal graph? Actually, I would say it's unimodal. There seems to be one peak that's more significant than the others. Yep. The third thing about shape is outliers. So always be careful to point out the outliers in a distribution, those values that stand off away from the body of the distribution. So outliers can affect every statistical method. It can be the most informative. It could be an error. So whatever it is, you need to discuss this in your conclusion. Let me give you an example. Let's say I'm studying US personal wealth. Okay, so I'm studying personal wealth in the United States. And now I can look at every single person in the United States, but as we know, that population is extremely large and it's just not practical for me to do that. So I decide to take a sample since I'm studying US personal wealth. So I look at a few individuals across the United States and include them in my sample. But the problem is, in this sample, I happen to have Bill Gates. So if I'm looking at the data in my sample and I'm trying to figure out what the averages are or the typical values are for US personal wealth, it's going to be completely distorted. My conclusion would be really incorrect because I've included Bill Gates. So an average US personal wealth statement would be totally incorrect because of Bill Gates. So that observation that I have for Bill Gates, that value, that data set, now has this atypical value. That atypical value is a special feature. It's considered an outlier. So he would be an outlier in that data set. But remember, an outlier is not an extreme value in a long tail. Okay, that's still fairly typical in your data set. I'm talking about something that's completely atypical, completely different, unexpected, does not make sense in your data set. That would be an outlier. Okay, any questions for me? Okay, so let's do this together. And I'm going to do a polling on the side here. So there's two questions. Let's look at question number 1 first. Question 1 says, following is a histogram of salaries given in dollars for a sample of US marketing managers. Comment on the shape of the distribution. Okay, so you're looking at a histogram and you have to tell me. So the first one is, and I'm typing it up into the polling here. Is it uniform distribution and left skewed? Second option is it unimodal and right skewed? Is it bimodal and right skewed? And the last one is cannot be determined. Okay, so you should see these choices. Looking at the histogram, what do you think? Okay, couple more minutes to answer the question. Okay, and I'm going to stop the polling now. So you can see here most of you chose unimodal and right skewed, and that is the correct answer. So unimodal and right skewed is the correct answer. So if I looked at this histogram, it's not a uniform distribution. Okay, so right away I can eliminate A because uniform means all the bars are about the same height. I can eliminate answer choice D, which says cannot be determined, because actually I can determine it. So C is saying, yes, it is right skewed, that's correct, but it's not exactly bimodal. I don't see two peaks that are quite significant. So for that reason, answer choice B. Okay, any questions for me? Okay, let's look at the next question. Question number 2 says, the following table shows data on total assets given in billions of dollars for a small sample of US banks. Prepare a stem and leaf display. Comment on the shape of the distribution. Okay, so again, this has been distorted a bit, but let me. So you're given a bunch of numbers. These are the assets, and you're asked to create a stem and leaf display. So the first thing you're going to do is to rearrange your data in increasing order, right? So let's do that together. You have 58, 70, 80, 81, 84, 88, 89, 92. Okay, so you have your data set now in increasing order, and you have to create a stem and leaf display. So that means the first digit is your stem, your trailing digit is your leaf. And then turn your head sideways and comment on the shape. So you have 3 answer choices there. Is it symmetric, skewed left, or skewed right? Okay, you have 2 minutes to do this. Okay, you have a minute left. Okay, and I'm going to stop the polling. So make sure you answer. Okay, so you can see here most of you answered skewed left, and skewed left is actually correct. So if you do this and do the stem and leaf display, turn your head to the right, you should get a data set that has a long tail to the left. So yes, that is the answer, skewed left. And then this is how the chapter is actually organized. This is the last slide for today. So I wanted you to see that the goal for today's class was to show you how to create your 2 table and create the graphs for histogram, polygon, and ogive, and then we talked about the shape of a distribution. In the next class, we'll talk about center, spread, and everything else. Okay, so that's it for today. Enjoy the rest of your day. If you have questions, I'm still here. Priscilla, go ahead. Priscilla, did you have a question?
Yes. Sorry. I just wanted to know what columns do I highlight to create a polygon? I forgot.
For the polygon, it's the
Yeah.
same thing like the histogram. So the first two
Okay.
columns, class and frequency.
Okay. Thank you. That would be it. Thank you.
You're welcome. Elizabeth?
Yes, hi, Professor. You mentioned that the slide should be under course materials, right?
Uh, no, not in Blackboard, in my
My,
lab.
or in my lab. Okay,
So course tools, document sharing.
okay, perfect. Thank you so much.
You're welcome.